Yeah, last year our first prize winner is Anil Kuma's Bytom Swap team, and this year PayPal team actually they get a larger prize award than last year. So now I'm happy to have Haoyu Lin, core developer of Bytom, to give a speech about process-oriented smart contract. Let's give him a round of applause.
Hi, everyone. I'm Haoyu from Byton. Today I'm going to give a talk on Byton smart contract. What I'm gonna talk about today is first I will gonna explain on the differences between the UTXO model and Ethereum account model, and also I would also like to explain further on the characteristic and design principle of Byton UTXO model. And last but not least, we will walk through some example together so that we can have a better understanding on how to write your own smart contract in Byton. So first of all, what is UTXO? UTXO is short for unspent transaction output. And as we all know, blockchain is a distributed database storing transaction history. And blockchain literally is a chain of blocks. And they store transaction inside, the transactions are stored inside the blocks, and each block refers to a previous block up until the Genesis block. And the longest chain is considered ID and deployed the contract you need onto Byton. And similar with Bitcoin, in Byton, different UTXO cannot communicate with each other. By that, what I mean, because in script language, no script OP code that have the function, you can understand that in such a way. OP code can look at anything that is not in the transaction spending from the script. Otherwise, because we want to support pruning mode in Bitcoin, and if we adding the data reference mechanism into Bitcoin, that it won't be efficient to prune our block data to save our disk space. And because an OP code might refer to a transaction output that has been spent in a very early block. So pruning mode is where the UTXO is written, and is a way to reduce the disk usage. And also another reason is that the script interpreter is run only once at the time the transaction enter the memory pool, where those transactions that hasn't get confirmed in the blocks are stored. And thus, it cannot get information about the block it is. Instead, the script interpreter can only has input only that transaction is attempting to spend. Like there are also several discussions on Bitcoin develop mail list, talking about the transaction buff data, and maybe another topic is OP local output, which is try to figure out the state of a previous output. Is like because an output can actually go to different direction, depends on the condition, depends on what condition is fulfilled. Is it fulfill the time lock, or is it fulfill the hash contract? But those discussion actually shows that it would not be a good idea to adding stateful transaction onto Bitcoin. So, and then I would like to walk through some example of Byton smart contract with everyone. Like the first example I want to show is named lock with public key hash. It's actually pretty much how Bitcoin's pay to public key hash script is, but having multiple asset support. So as you can see, in such a contract, we need to provide a public key hash to deploy it, and we lock some asset. We lock some value of a specific asset onto the blockchain, and the keyword locks actually is pretty much what it does is pretty much like the picture I showed you before. Like in the locking script, you actually transfer some amount asset to an output, and then these assets are actually, you can consider it, lock it until you provide the necessary information to spend it, which is pretty much like unlocking it. And that's also how Byton does in Byton lock with public keys hash contract. So after we deploying such a contract, we can actually invoke the spend clause by providing the public key and the signature of the transaction. And then the virtual machine will like do a hash on the public key and verify that the public key's hash is indeed the same as the public key hash during the setup process. And then you just check the transaction hash signature, whether it match with the public key signing the transaction. And if the verification succeeds, then the amount of the asset is able to be unlocked. And I would also like to explain more on Byton contract as shown below, all the contract parameter which is public key hash here. They are constant and cannot be changed after setup. And close is the enter point to unlock the contract. A user need to provide the close parameter, which is public key and signature here, to unlock the contract. And the verification result will be either success or fail. And the second example I'm going to give is called review pre-image. It can be used as a simple brain worry. So basically, you have maybe a string in your mind, and then you hash it, and you can use the hash to set up such a contract. And you lock your asset into the contract. Once you want to retrieve your money back, you just invoke the review clause, providing the pre-image. Then the virtual machine will, according to such a smart contract, the virtual machine will verify that the pre-image hash is actually equals to the hash you set up. And then once the verification is done, you can indeed unlock your asset and make the transfer. And here is a decentralized exchange example. So you could set out the asset request and amount, and the price, and who is the seller, and we can also make payment for it, as long as the amount meets the requirement, and the seller can also cancel the transaction, providing the signature, and that is crowd contract. So basically, just having an agent to approve or reject the transaction. And we also have recursive defined smart contract, which distinguish our smart contract from Bitcoin script language. So for a company share, if we want to change a member of the board share, then actually we don't need to define a branch of contract, but we can just define them recursively. We set out the time lock, and then we lock the amount onto it based on different time. That's all I want to share today. Thank you.